Hello guys, and welcome to the afternoon session of webinar number 6. Today it's about common printing failures, and my name is Robert.
My name is Robin.
And it's great that you joined us here for the webinar. One thing, if you have any questions about any topics we have here in the webinar, please put them in the chat. We cannot hear you on Skype, so just put all the questions in the chat and then we can talk about them after each corresponding section. As always, if there's a bigger question coming up, we would like to move that to the very end of the webinar to have a little bit more time and to keep the flow of the webinar alive. All right, so let's check out the agenda for today's webinar. What you can see here is we have 4 points or 4 topics. The first 3 are the machine management, the job preparation, and material comprehension. All of them are there to summarize or to sum up all the knowledge what we already presented in previous webinars, and they're also there to discuss all the preventive measures you can perform before you start a job. The last chapter, chapter 4, there we will show some common failures, we will show some sample pictures and how to troubleshoot them and how to resolve the problems. All right.
So let me just take over. I will just start with the first point, machine management. So in order to prevent, like Robert said, all failures, we want to manage the machine properly. This is now again just a short wrap up of what we already discussed about, and it's all coming down to the user maintenance of the machine and the accessories. So if we just have a look in what is the user maintenance, it's up in 4 parts. So the first part is the daily maintenance. Daily maintenance means mix the resin. For example, resin was in the machine or in a longer time in a bottle, overnight, whatever. You will have to mix it before you want to print it in order to get proper results. Next one is check the optical surfaces, especially when there's some resin was dripped because you removed the part and it was just dripping somewhere, or you removed the platform, before, you removed the reservoir before you removed the platform and there's something dripped or spilled somewhere. Next one is if you got a failed job, of course, you will have to filter material, clean everything up and check the reservoir. That's it for the daily maintenance. Then there's the weekly maintenance. You should do, as always recommended, to do the auto calibration once a week. It was presented in one of the webinars, how to do the auto calibration. Next step is also check weekly the safety glass, really. If there's some scratches, if there's some other damage, or if there's some cured material on it, to prevent unexpected results. Same is for the reservoir condition. Reservoir, there's a glass on the bottom and the Teflon foil on top. Both of them should be clean, should not be damaged in order to get the best results we can. Also, there's the monthly maintenance. Monthly, we recommend to check the build platform. So in order, is it parallel? So check the parallelism once a month, or even if you drop it, you can check it directly after the drop. You should especially check it after you dropped it. And you can check the surface of the base plate of the build platform. If it's a little bit shiny, it might be worn out and the platform or the part won't stick properly to the platform. Second thing you can check monthly or recommend to check monthly is the stray light. I think also Robert showed you where to find the stray light function and how to check it. And last but not least, which is something we talked a little bit but not in detail about, is the yearly maintenance. So the yearly maintenance is the remote maintenance and the sensor recalibration. Both of them are included in the remote maintenance contract, which is the first year for free with the rapidshape machine. And the remote maintenance is done by rapidshape, so by us. We will check through the machine once a year, check everything, check also if the updates can be done and so on. Additionally, there's the sensor recalibration, which is quite important as the sensor is really calibrating the power you are printing with. And if the sensor is outdated, you might not get the real estimated power or the power we used for the parameters for the material, but less or more, which is then also leading to unexpected results. So this is also the yearly maintenance. I think it's already the things we need to know for the user maintenance. These are the 4 steps, the 4 timelines we have for special maintenances. And I think we can just directly continue with the next topic, and I would hand it over to you.
Yes, so yeah, Robin, you wrapped it up really nicely about the user maintenance and all the related topics. So I want to discuss now the job preparation. Job preparation, you might think, yes, there was already a webinar. We discussed all the indications, what are available for NetFab. Why are we talking about that again? So when it comes to troubleshooting, most of the times the customer gives us a call and tells us, hey, my job was not printing. And then we have to figure out first all the basics. So has he done all the basics in the correct way? And the very basics are for us, has he used the correct workflow in NetFab? Has he used the correct printer? So it could be a wrong machine type, set it up. And also we need to check if the corresponding material was selected correctly. So it could be that he has bought a certain material which shows a different name on the label what he has selected in NetFab, and therefore it cannot be used because as you all know, all materials have very specific parameters like curing time and force start time. All this stuff is different from material to material. So it might be that he has used the wrong material parameter. Well, placement is another big topic. As we all know, on the build platforms there are a couple of holes on the corner. In the center there's an area without holes. So that might be the right place to put some gingiva parts, some stumps in there. So everything where you have a flat surface and you have very small, tiny parts, you should put in the center. Other than that, as soon as you start to use a support script for your STL file, you should always consider using a base grid as well. Otherwise, you might end up putting a support right on the hole on the base grid, on the hole on the platform, and therefore you might lose it completely. So placement is crucial together with the supports, what I mentioned together here. So if all these steps are done in the correct way, most likely it should be fine, but then again, even with advanced users, you might see it from time to time, they are in a rush, they are selecting something wrong, maybe there's a new worker on the system with not so much experience, and some easy failures can be prevented by just checking all the basics. All right, so far I can see there is no question. I hope that this answered your questions you had, so I think we can proceed.
Yes. So now we got the understanding of how to check the printer, how to check NetFab preparation and so on, which is really crucial for the troubleshooting. To have just a short look into the material comprehension, because it's sometimes also quite helpful to understand that materials can behave or should behave differently. So just as a basic, what's the resin we use? In the beginning, it's fluid resin before the printing. It's highly photoreactive, so UV light is dangerous, and it's not biocompatible. So after the printing and the post-processing, it's non-photoreactive, it's biocompatible, depending on the resin you use, of course, and you only then have got the final size and strength or characteristics of the resin. Just let me mention, post-processing is the webinar of tomorrow, so I won't tell anything about the post-processing yet. You just need to know that only after the post-processing the part is really finalized. So this means for us to understand each process properly, each indication needs a different material or resin with different characteristics. For example, gingiva. Gingiva is soft and flexible, or ortho model is strong and rigid. Also, the resins itself, while printing, behave differently. And this is what we always have to keep in mind. We cannot compare one resin with the other and say it's the same issue. So this is always an interesting fact. Don't compare resins directly to each other. And just to be sure, to sum it up, so it means also for us, each material has its own parameters for printing process, cleaning process, and post-curing process. So it means if we check NetFab and so on and everything is good, we still have to check also the post-process, because if you cure a material with some other process parameters than recommended, you will have got unexpected reactions of the material. Okay, so I hope this was not too fast, but as usual, we still got the webinars uploaded, this one and also the other ones which are building up for this one. And for now, there's no question, so I think we should directly head into the main topic of today, the common failures.
That's what we're all waiting for, I guess, common failures. So guys, we just want to show you some examples of common failures. I'm sure that you experienced already lots of things out there in the field. If something what you experienced is not here in the webinar and you want to discuss it in a future webinar, please let us know. Please give us feedback about topics you want to discuss. I'm sure we couldn't put all the common failures in here, but just let us know what you want to discuss in a future webinar when it comes to troubleshooting. All right, let me start with the first example, what we have here. And if we take a closer look, we can clearly see that we have color differences. So imagine that this job was printed, or these two parts are printed with the same resin. And we have two very different colors here. So one is a lighter green, the other is a bit more opaque, darker. Why is this happening? So that could be that, or it could be that the resin what we have used was just not mixed well. And we also have another picture here at the bottom where we can take a closer look. Even in one STL file or in one printed part, you can see different shades of color in there. So you can see on the left-hand side, it's a bit more beige. On the right-hand side, it looks a bit more white with white particles. And if you go back as a solution or as a to sum up what happened here, we would say that the resin is just not mixed well. And especially for certain resins where we have color pigments inside, or resins with a specific viscosity like gingiva material, it could happen that if you leave the resin in the reservoir for quite some time, we talk about maybe a week, a couple days, a week or two, it could happen that this resin got separated into two different types of liquids. The one on top is most likely a bit more transparent, the one at the bottom is a bit more opaque. And you can imagine if you have two different types of resin inside, or two different liquids inside, the parameters will not work well. And it could happen that either your job failed completely, or only a part of the job will be printed well. And even if part of the job is printed well, I would doubt that we have a perfect job result when it comes to color, quality, and also accuracy of your part. So what we should do is mix the material well before you put it in the reservoir. Even if, let's say, your bottle is standing on your desk for some time and you put it inside without mixing well, you could have the very same problem. So shake it well before using, and if the resin is already in the reservoir in two different states, you can use the rubber card what we also ship with the machine to mix the materials well until you get one homogeneous resin in the reservoir. So that is a really crucial thing to do. As you all know, we also have the mixing function on the machine. That means when you start a job or the customer starts a job, the machine is performing a mixing movement. So the C-axis is just moving up and down in the liquid in order to mix it a little bit. But you can imagine if there is such a big separation of really having two types of liquid inside, that is not enough to make just some movement before you start printing. Yeah. So please be aware of the fact that the customer is responsible for the homogeneous of the resin inside. Okay, that would be the very first one. Happens from time to time. Also, we see that in office in the service department that there's maybe a material you do not use quite often, and this is something which we also discover quite often, that this must be mixed. Okay, let's move on to the second one. This is also something which is related to colors. Here we can see the shade of a temporary down here as well. So there are other possibilities. If we have checked that the resin was mixed well, there can be something else going on, that we have problems with the colors. So in this case, I would refer to the post-processing. Again, as Robin mentioned earlier, this will be something we will discuss tomorrow in tomorrow's webinar. But just to give you an idea of what could happen here, wrong post-processing, what does that mean? It could mean that the customer is using a validated cure or a curing machine the wrong way, so with wrong parameters, or he's just using no curing chamber at all. That would be the worst case. It happens also from time to time. Or he's just using a non-validated post-curing chamber. So in all these cases, we get problems with the color, we get problems with the accuracy, and also the biocompatibility.
Yes.
So this is also not given as soon as the customer is leaving the validated workflow. Well, for best, let's say, best accuracy and best color results, we would always recommend that you use the P-Cure, P-Wash, or RS-Cure, RS-Wash, because there we will find already all the necessary parameters installed.
Yeah,
so
really easy to use.
It's super easy to use. It's great for peace of mind. So just select the job you have printed, and this way the washing cure, they already know, okay, it must be this material, so I have to use these specific parameters. All right, so that would be the second failure what we have here. Now I think this is something you're all aware of, and this is something pretty common in the field. This is a model with a crater, a big hole inside, and this is happening mostly with hollowed models, and I'm quite sure you can imagine what that is. This is all about supports. So supports are not used here on this hollowed model. We have another internal low point, so the teeth is going inside. We call them islands because this is something you can observe when you check out the result of the slicing process. So when you check out the layer pictures, you will find when you scroll from bottom to top some islands which appear all of a sudden, and this is a non-supported area which will fail or which will cause problems with your parts. So please use always a support script if you are not sure. Use the quick support what we offer in NetFab. This is working fine, and this way you should be able to prevent these problems what you see on the picture. If you want to have a in-depth explanation, can be found in webinar number 2, chapter 4, support. All right. I can see that there is a question coming up from Gabriele about for Andre. Maybe we can just put it in here as well. It's about the information of the post-processing about temporary pre-pro resin. Maybe we can talk about that later. Yes. I think it will be better when we put that to the end of the webinar. Let me proceed, please, with the slide or failure number 4. This is also something which we can see from time to time. So that looks like a tray. So the customer wanted to print a tray STL file, but it was not finished completely. So how could that happen? Now this is something pretty trivial to solve, yeah. An easy thing to solve, but it happens. So you could end up having not enough resin in the reservoir, and therefore what the machine will do, it will just proceed with printing the layers, or try to printing layers. So the C-axis movement is still there, moving up, down. The light engine obviously will also still project the slice image onto the reservoir, but there's not enough resin in there, and therefore no connection to the previous printed part. So that means you just have a clear cut in one layer, yeah, it's just not enough resin in there. So easy thing to solve, just take care that there's enough resin inside. How can we check that? There's a maximum marker on every reservoir we sell, so just make sure that before you start printing, you just fill up completely to the maximum marker, and this way we never have to worry about this failure again.
Yeah, and additionally, the machine is mentioning, for example, after X amount of print jobs, please check if there's enough material in the reservoir. It's obviously for this reason.
Yes, so this is something the machine is just doing by counting.
Yes.
So we cannot really measure how much resin is inside, but the machine is assuming, okay, after a couple print jobs, we might want to give the customer a reminder to fill up the reservoir to a certain level. But basically, or ultimately, the customer is responsible to put enough resin in the reservoir. All right.
Okay, so
I can see that Tony is mentioning that we lost video. Is this true? Oh, it's just, okay, it looks like it's just Tony. Guys, we had the problem earlier today in the first webinar as well. There were some issues with the streaming, so maybe the internet or the bandwidth is not good enough here, but no need to worry. We do a record of this session, and at the end you will get a working video with good audio, good video, and
yes.
you can or just watch it again on our homepage.
You might also reconnect. So if you just close and reconnect to the call, it might be that you will see the video again, because it seems like it's not all the people who lost the video.
Yes. All right. Let's proceed with number 5. Number 5 is something which looks really strange. We have cracks all along the model. So this is going through several layers, not only a certain layer. We have also a surface which looks really, really ugly. There are lots of positive lines on there, and it looks like it looks really bad. So we do not expect something like that. So all these two pictures what we see here are all related to energy. Energy is a problem or something which we can solve by calibrating the machine. Robin mentioned that earlier. It's all about the weekly maintenance and doing the auto calibration. Basically, we just want to check, was the calibration performed on weekly base? Could happen the customer forgot about this, or is maybe this LED sensor expired? So as you all know, there's an expiration date on the LED sensors. This is a year from delivery, which means after a year, the sensor must be shipped back to rapidshape for recalibration to make sure or to ensure that the sensor is working in the correct range of power output. All right. It could also mean that, again, the wrong parameter was selected. So as you can see, there are many variables here. So we cannot assume that by just having one picture, it must be this root cause. So there are always some possibilities, and we just want to check out all the, or we want to delete all the variables to just make sure, okay, at the end we have the root cause for that. So wrong parameter could be the root cause. Stray light level could be too high. That's also pretty obvious, especially for the second picture. The light cannot travel through the glass elements anymore in a straight way. So there's some stray light, and basically what we see here on the second picture, really nice, is that this will cause some additional curing on the surface of the part which we do not want to have. All right. So I can see no questions so far. Let me proceed with number 6. Now, this is something which is also pretty common. Unfortunately, it could happen that a part is not connected at all, or only a part of the part is connected to the build platform. So that could mean that the build platform is maybe not parallel. So we would advise the customer then to check the parallelity of the build platform. How this is done, we presented already in the previous webinar last week together with Ignatius. Then again, could be the material parameter in NetFab. By using a wrong parameter set, the burn-in factor is wrong, or in general, the curing time is wrong. Therefore, connection to the build platform is not given. And then it could also mean that, yes, we have used the correct parameter, but the burn-in factor is wrong. So then you just go into the material parameter settings in NetFab, you check out what is the burn-in factor of the material, go back to default. If this is still not enough, we have problems there. It might be that the platform is just a bit old, and therefore the connection between the printed part and the platform is not as good as before. That means either increasing the burn-in of the material, or we want to roughen up the build platform using sandpaper. So like a refurbished platform. Yeah. If you do that, please take care that you always contact us first, that we can help you with the analysis of this problem, because for roughing up the build platform you should get some guidance of the rapidshape team. Alright, I think we can proceed with the next one. Now this is also something really common. It is a little bit similar to the first picture we had, or not the first one, sorry. The second one we had with the model with the crater inside, maybe you remember. Here we also have a crater, but we cannot see through the model. That means that it is not related to a support issue. So the model is printed, but all of a sudden a part of the model is just ripped out of the printed part. So the reason why that could be is, let's take a look at the second picture. It could be that the reservoir is damaged in a way that either there is a scratch on the Teflon foil or a bubble between the Teflon foil and the silicone layer, and this will cause a different adherence to the reservoir, and therefore part of the model might stick a little bit more to the reservoir than to the previous printed layer, and therefore it's just performing or making this crack. It could also mean that maybe there was already a small cured element in the reservoir before you started the print shot. And therefore this is also getting cured together with the printed part, and this is also causing a crack during the print shot. So we want to make sure that the customer is filtering the material, so put it back into the bottle with using a filter and a funnel, clean the reservoir well according to our instructions, what you see on our homepage. And afterwards you can check the status of the Teflon foil by just holding it against the light like we did here on the picture, and then you can send us a picture for further analysis. And but basically, if there's a bubble, you cannot print in this area anymore, and once you have a bubble it gets bigger and bigger over time, so then we really have to consider buying a new reservoir. Alright. So I think I will proceed with the next and last picture. Here you can see that this is a part which has a lot of additional curing on the surface, and there's also a lot of light coming in, and this is basically also the root cause for this. So every UV light you have either in the printer or coming from outside is just causing problems. So that means we have actually two solutions for that. It would mean, okay, it can be caused by stray light. So again, it would be cleaning the glass elements. That would be the protection glass, which is on top of the light engine, or the bottom glass element of the reservoir itself. Or you could have also some UV light pollution coming from outside the printer. We have this from time to time, that a customer wants to, or he did disable the auto hood function. He started a job, going out, getting a cup of coffee, forgot about the fact that the hood is still open, the machine started to print, and then you might have just on, like you see on the picture, an area where is some light pollution. So in this area you cannot use the part. Might be that in other areas it's not so bad, but basically make sure that the hood is always closed when you print. We would always recommend you to use the auto hood function for safety measures. All right, I can see that there's a question coming up from Sean. How would you diagnose a hollowed model that has printed for a bit but has separated from the build platform and has bonded to the reservoir? Yeah, actually we are already moving forward. Thank you.
Yes, I will just do it like this because I think that's now the topics.
This is great. Yeah, this is something we definitely have to look a little bit closer, to. So if there's separation in just one layer, it would mean that, like we see in the previous pictures, maybe the resin level was not enough, but I assume that this was correct here. So that we really have to take a closer look in all the variables, like what was the job information, was the reservoir maybe damaged, or what was the calibration status of the machine, was it calibrated well, what's the status of the light sensor, was this calibrated on yearly base. So there are lots of variables I mentioned, or Robin also mentioned. earlier on, and then we have to just disable them to find a root cause for that.
Okay.
About what you said, is it more common in the P10 series? So this is not something we discovered.
No.
And the last thing.
So yeah, but maybe for you, Sean, you said it's separate from the build platform. So it depends if it's separate really completely from the build platform. Then maybe it can also just be the burn-in factor.
Burn-in, yes.
Because if you reduce the burn-in factor,
yes,
then the first layers will not be sticking so good to the platform as in a normal setup. But the normal layers are still printed with full energy, which means there's a lot of force which will be separating the layers. And if the first burn-in layers are a little bit too soft, they will just also lose connection because the force is just too strong, the tension is too much to bear.
Yes.
So this could also be a reason. And I can also see Gabriele wants to improve stray light and asked if you can do it with the advanced calibration and check that there's no dust on the optics.
Yeah.
So checking that there's no dust on the optics, perfect. You check, of course, first stray light in the safety glass if it's clean, and you check then by carefully looking into it if the lens is also clean. Regarding the advanced calibration, that's why Robert maybe also laughed a little bit. There might be a possibility that the advanced calibration is causing stray light, but only if the advanced calibration was changed already.
Yes.
The one which is delivered with the printer is done at rapidshape, and we are in a range where there is the least stray light we can get. So as soon as you change the advanced calibration to a higher or lower value, I don't know exactly the values which are the borders, but I think it's around about 160 and the lowest point 170 maybe, and the highest point 230. If we really go higher or lower than this, there might be a bigger chance that we get stray light. So usually don't touch the advanced calibration, check it with us if there's any other possibility or solution for this, and then we can have a look, for example, for the advanced calibration. But usually there's at the beginning no need to change the advanced calibration.
Yeah, that is correct. And I would like to add that the advanced calibration is also done on the remote maintenance every year. Yes. So this is already, or this will be checked by us together with the customer during the remote maintenance. So as Robin mentioned, we shouldn't touch it until we figure out that this must be the root cause for this problem. But Gabriele, you said it really nice that it's about the optics. So we really have to check the optics there and make sure that everything is super clean. And when we still have problems with the stray light, yes, then we can start looking at the advanced calibration. Yeah. I can see a couple more questions popping up from Antonio. Let's start with Antonio first. The burn-in factor on the P20 is set at 50%, on P10 is set on 2200%. Is this a mistake in that fab? No, it's not a mistake. It's on purpose. We did it on purpose. No, this is all about the different build platforms that we have there. So as you know, on the 10 we are using the plastic platform, whereas on the 20 we are also always using the metal platform. And therefore you can assume that for printing the same material on both printers, we have to use different burn-in factor to ensure that the first layer is connected well to the build platform. So that's on purpose, so that's not a mistake. It must be like that. I hope this answered the question. I have experienced
Tony
many model failures with P10+. Yeah.
So yeah, maybe Tony, if you experience a lot of model failures with the P10+, it's really interesting to know what kind of failures. So best is send pictures, send a short description what happened, so that we can, so via email in the service inbox, so we can really elaborate what's going on. I think that's the best way, because for now in the webinar it's really hard to get into the details right now. But please just send us a mail.
Yeah, but this is actually something we are facing every single day. So customers telling us, I have model failures on P10+, and then we have to figure out what kind of failures they are. So is this a complete failed job? Is just part of it broken, or was it not connected on one side, or whatever? Could be many things, and we have to get all the details first before we start troubleshooting this case.
Yeah, so Young, I can see you also wrote a question. I think this is what we also can discuss via
Yes.
email with you, because this is a really more in detail thing, which is really just advanced knowledge. So let us just discuss this via email then.
Yes, but thanks for your input, Jan.
Yes.
Always appreciated. Then we have a question from Antonio. When raising the burn-in factor, by how much you raise it, can you give more advice? Yes, we can. So we would always say, if you have problems with the burn-in factor in terms of that the part was not sticking to the platform, we would always recommend to just increase it by one step, which is 50%. So please do not just raise it to the maximum immediately, because you might end up having problems to remove the parts from the platform. So just do it step by step. If it's not working well, increase it by one step, which means 50%, increasing the burn-in factor. So you have a little bit longer exposure time in the very first layers. And that should help. If not, increase it another step. But be careful with that. Just doing step by step, not more than that.
Yes.
Okay.
So we still got time left. So
amazing.
that's good for you. You can ask more questions. We're still here for you.
That is great.
So maybe until the questions are coming in, just let us quickly summarize. So what's troubleshooting usually all about? Well, in today's webinar, what we've seen, the common failures are all based on, let me say, the basic maintenance and the basic topics of a printer, which means it's a bit tedious for you maybe, because you think, why can there be some issues? But it's all about checking the basics first. Most of these, or all of these failures we showed you today are based on basic issues. So it might be calibration, it might be raw material selection, and so on. So everything starts from the beginner level, even the failures. So always check it from bottom to the top level issues.
Okay, Yang, one more question. An issue you saw twice in China. Customer removed the Teflon foil and silicone. Oh, that's a good one. Let me talk about that, because I can remember in my early days here at rapidshape, many years ago, that we had a similar case, and the customer had resin in the reservoir, and it was an opaque resin. And I can remember that a service colleague from us, he recommended the customer, please try to find all the cured elements in your reservoir and try to remove them and print again. So there was a print failure. The customer thought, okay, it might be a good idea to use the metal spatula, and he just went into the resin, in the reservoir, threw the liquid, and he just felt, yeah, there is something. And actually he removed the whole silicone layer together with the Teflon foil.
That's good.
And you can imagine that removing the silicone layer and Teflon foil is damaging the reservoir permanently, so you can't use it anymore. Because imagine you are printing with a metal platform moving on top of a glass, and none of the parameters will work. You might even make a greater damage, so that should not happen, but it is real life, so we saw lots of interesting things here. So this is not something which just happened for you, Yang. We also have seen this not often. It was maybe 1 or 2 times, but I can remember it happened before.
Yeah.
Well then, Antonio, can the P10 platform be reused? Well, this is a one-time platform. So. As you know, we sell the P10 capsule as a capsule system. So in this capsule, all the elements you find, the components, are one-time use. That includes the build platform, that includes the resin bag, or the small capsule with resin, and it also includes the
reservoir.
The reservoir. Thank you, Rob. So no, we can't use them again. I guess some customers are doing that, but we would not recommend it.
Yeah, so I think it might work if you're really carefully in removing it, but yes, it's all about recommendation or not, so.
And Shaw has a very good question. Let me read that. Do you find that there are more failures using specific model making programs? That inconsistencies in the STL leads to more failures? Yes, I think we had the topic earlier this morning already. It's a very good one. So yes, in an ideal environment, we would love to see that the customer is only using design software where a rapidshape setting for models is already implemented, which is in Straumann Cares and DWOS. So there is a rapidshape setting for the model, and then they will be designed in a way that there are no inner islands, some low points which we have to support. So this is something where we get perfect STL files out of it. But yes, there are other model making programs, design software, which creates, for example, a model with a certain wall thickness and a static wall thickness, and therefore this will cause low points and islands. So yes, you're totally right, Sean. It really depends what the customer is using, and therefore we have to check on site during installation what is going on, how can we assist him with his setup, what he has.
But I think this also then comes down to the user itself. So yes, of course you can use other design programs, you just have to understand how the design software is working and what designs, for example, if you hollow it, are the output. Then you still can work with it. Maybe you need some support or not, but it's most likely you can use any design software, you just have to understand it, and then it's totally fine.
Exactly. There's always a workaround for pretty much everything here. Then Gabriele, do reservoirs have a general deadline, or does the customer need to change them only if the reservoirs are damaged? That is a good one, because yes, the reservoirs have a deadline. We say the
not
minimum.
General deadline, I would say.
Exactly, it's not a general deadline. It's more like a minimum jobs which they have to perform well, and that is 300 jobs for the glass reservoirs we have for 20 and 30 and 40.
Yeah, I think that's the average.
That's the average.
Yeah. So the average, which we say it will last, it's 250 to 300 jobs.
Yes.
And of course, depending on how the customer is using the reservoir, it might be done after 20 jobs and you can't use it anymore.
Yes, we have seen that before, but it really comes down to failures in NetFab, so mistakes they made by using, let's say, a solid base plate, for example.
Yes, or metal spatulas.
Metal spatulas in the reservoir.
Yeah.
But yes, there is some minimum average job number which we want to see from every reservoir. But if the customer treats the reservoir in a good way, it could happen that you print much more jobs with that. So
yes, there are some which have printed a lot of jobs and we were still surprised, but all comes down to the user maintenance again.
Exactly.
Okay, so Antonio is asking, is the wash and cure currently connecting to the printers? Yes, Antonio, it is. We also plan to have one of the following webinars about the cure and wash. And I think we also then will have a quick look how to interconnect them with the printer to see how it's working and how to set it up. And well, I can't tell you directly the timeline when this is going to happen, but it's one of the following webinars. We still have got some webinars in our timeline we want to do. Especially one would be cool if you just, like Robert already asked you, send us some important tasks, important failures which you have experienced, but which were now not mentioned. Of course, we just mentioned the common failures now, so you will have some examples. We maybe also want to bring out in a webinar and put some more details in there why this could happen. So just let us know, send us an email, and then we can have some more webinars just for you.
Yes. Okay, I think we have managed the questions so far. If there's nothing else, I think we can say thank you.
Yes.
We can say thank you for your for joining the webinar, giving us all these interesting questions. So it's a really nice interaction between you and us, and we really appreciate that, and also the input you give us. For today, I would say my apologies for having no native English speaker here, so you have to deal with two very strong German accents. I hope it wasn't too bad for you guys.
Well, we tried our best.
We tried our very best. Yeah.
So then, as usual, we would like to see you again in the next webinar. And until this time, stay safe and stay three-dimensional.